Our goal today is to know how to use ratios to make predictions, but I'm going to show you two different ways to do it. Okay, I'm going to show you how to do it with a table, but then I'll show you how to do it with equivalent ratios. Okay, so here's our first example. It says, during Christmas, a bookstore sold 72 books. If the ratio of books to bookmarks sold was 9:2, how many bookmarks did the store sell? Okay, so to give us this relationship, books to bookmarks. Okay, so I'm going to make a table with that relationship. Books to bookmarks. Okay, books is mentioned first, and the number 9 is mentioned first. So the 9 corresponds with the books, and the 2 corresponds with the bookmarks. Okay, and what it means is for every 9 books they sell, they also sell 2 bookmarks. Okay, but what if they didn't sell 9 books? What if they sold 18 books? Well, then they would have sold 4 bookmarks. So every time the books go up by 9, the bookmarks go up by 2. And what if they sold 27 books? That's 9 more. Well, the bookmarks would go up by 2 more. Okay, so the ratio tells us the relationship, but it doesn't tell us the total number. Okay, this problem, though, tells us that they sold 72 books. Okay, so the top part of this table where we have books, that should go up to 72. Okay, so I'm going to keep adding 9 each time. Okay, it's helpful if you know your 9 times tables. So the next one would be 36, 45, 54, 63, and 72. That's the number that I'm trying to hit. Okay, so if they sold 72 books, then how many bookmarks did they sell? So I'm going to continue the bottom of the table, but remember the bottom's only going up by 2. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, so how many bookmarks did the store sell? Your answer would be 16. Okay, so we continued the relationship in this table until we got up to 72 books and 16 bookmarks. So the ratio helped us make this prediction. There is a shortcut, however. If you can figure out how to get from 9 to 72 without writing them all, then we can figure out how to get from 2 to our missing number. So 9 times what would be 72? Well, it should be 9 times 8. So if we do the same to the bookmarks, 2 times 8, that would have also given us our answer of 16. Okay, so let me show you that second way, how you would show your work for that. Okay, so you would start with your original ratio. They say books to bookmarks in a ratio of 9:2. We're going to make an equivalent fraction. So it's going to equal another fraction, but we have to see the other information that they give us. Okay, the other information that they give us is here, 72 books. Okay, so look at the key you made on the side. Okay. Books is your numerator. Okay, so that 72 is the number of books, so that belongs as your numerator. You have to make sure you're putting it in the right spot of your fraction. And we're trying to find the bottom, the unknown denominator. So you just have to figure out, well, how do we get from 9 to 72? What are we going to multiply 9 by to get 72? Well, it should be 9 times 8. So if I do the same to the denominator, okay, I can multiply the numerator and denominator by the same number. In the bottom, 2 times 8 would be 16. Okay, so that's the answer we got, 16 bookmarks. Okay, so this is a little bit of a shortcut instead of the table. Okay. We're multiplying by the same number. 8 over 8, 8 divided by 8 is really 1 that you're multiplying by. Okay, so these fractions in the end are equivalent. They have the same value. They look different, but they are equivalent. They have the same value. All right, we'll try this one 2 ways again. A fast food restaurant sold 35 burgers with cheese. The ratio of burgers sold with cheese compared to without cheese was 7-3. How many burgers did they sell? Let's change this. Let's just say, how many burgers did they sell without cheese? Okay, so my two things that I'm comparing, it's with burgers with cheese and burgers with no cheese. Okay, the 7 corresponds to with cheese, the 3 is without cheese. Okay, so maybe I sold 14 cheeseburgers, then I would have sold 6 regular burgers. Okay, so every time I sell 7 cheeseburgers, I sell 3 more regular burgers. Okay, but how far do I have to go in the table? Well, I have to go until I get up to 35 burgers with cheese. And the cheese is the top one. So it's helpful if you know your 7 times tables here. There we go. I got up to 35. Okay, so the regular burgers, I'm going to continue going up by 3. 3, 6, 9, 12. Until I get to that part of the table, the answer should be 15 burgers without cheese. Now, if they did ask for the total, we would just add them up. Okay, but I want you to be able to use the table to find your answer. All right, let's do it this second way, a little bit shorter. Okay, so I'm going to erase this. You can write it underneath. Okay, so my original ratio was with cheese to no cheese. And that ratio was 7-3. I'm going to make an equivalent fraction. Equivalent means equal, and it's going to equal another fraction. And the number that I have to put in there is 35 burgers with cheese. Well, with cheese was my numerator. Okay, so I got to be consistent. I have to put the cheeseburgers in the numerator. So how do we turn this fraction into an equivalent fraction? 7 times what will get me 35? 7 times 5 should work. So I'll do the same to the denominator. 3 times 5, my answer there, again, is 15. Okay, so 15 burgers without cheese. Yeah, we're going to do the rest of these the shorter method. Okay, so we'll use the second method. We'll use equivalent ratios. At an ice cream shop, the ratio of sugar cones sold to waffle cones sold is 6-5. Okay, so here are the two things we're comparing. Sugar cones to waffle cones. And the order is important. Sugar cones is mentioned first, so that 6 is for sugar cones. So for every 6 sugar cones, they sold 5 waffle cones. I'm going to make an equivalent fraction. Equivalent, think of it equals, and then I have to make a second fraction. Okay, the other information they give us, if there are 42 sugar cones sold, so that 42 is sugar, and I put sugar as my numerator, so I'm going to put the 42 there also. And we have to figure out how many waffle cones would be sold. So we're going to make an equivalent fraction. We're going to multiply the numerator and denominator by the same number. So think 6 times what is 42? Should be times 7. 5 times 7 is 35. Okay, so 35 waffle cones. Okay, we'll do 2 more together, and then you'll try one. At a summer camp, the ratio of boys to girls was 5-4. Okay, boys to girls was 5-4. Okay, for every 5 boys, there were 4 girls. But it tells us the number of girls. Okay, there were 40 girls. I'm going to make it equal to another fraction. Okay, girls is my denominator this time. So that 40 is going to be a denominator. And what do I multiply 4 by to turn it into a 40? 4 times 10 works. So 5 times 10 would be 50. Okay, so there are 50 boys. Okay, one last one together. While completing a race, Ned spent 63 minutes walking. If his ratio of time walking to jogging was 9 to 1, how many minutes did he spend jogging? Okay, so we're comparing the amount of time he spent walking to jogging. And for every 9 minutes he walked, he also jogged for 1 minute. Okay. And he spent 63 minutes walking. Okay, so walking I put as a numerator, so that 63 is going to be a numerator. So 9 times what is 63? 9 times 7. 1 times 7 is 7. Okay, so he spent 7 minutes jogging. Okay, here's one for you to try. Henry was playing checkers with a friend. The ratio of games Henry won to how many his friend won was 9 to 4. If the friend won 28 games, how many did Henry win? Please pause the video and try it out. Okay, the friend won 28. The friend I put as my denominator. So hopefully you put that 28 in the denominator, multiplied by 7 to make an equivalent fraction, and you got 63 games for Henry. Okay, one last one to try. Okay, the friend won 20. Again, I put friend as my denominator. So to make an equivalent fraction, I had to multiply this one by 5, because 4 times 5 is 20. And I got 25 games for Kate. All right, now I just want to look back at the number that we're multiplying by. So here it's 5 over 5. Here we did times 7 and times 7. Okay, same thing, times 7 and times 7. If I divided those numbers, so if I have 7 over 7, 7 divided by 7 is 1. Again, same thing, 7 divided by 7 is 1. 5 divided by 5 is 1. Okay, so in all these problems, I'm really just multiplying by 1. Well, what happens to a number when I multiply by 1? It stays the same. Okay, so these are actually the same. They're equivalent. Now they look different, right? They have different numbers, but they have the same value. Okay, if I wrote them as a decimal, for example, 5 divided by 4 and 25 divided by 20, I would get 1.25 for both. Okay, so they are equivalent. They just look a little different.